Well, good morning, good afternoon, or good evening, depending on where you're at today. It's a pleasure to join you and to participate in this task group as well. And we're looking forward to an opportunity to meet with all of you again in September. So looking forward to that. I want to talk a little bit about some of the smart cities efforts we're undertaking here at the National Institute of Standards and Technology. In particular, I want to start with something called the Smart America Challenge. And this was a project undertaken by Soko Ri and Jeff Mulligan, who are Presidential Innovation Fellows. And this is a program that brings entrepreneurs from the private sector into government for a year to bring in fresh new ideas, start new directions, get new momentum, and they have certainly done that with the Smart America Challenge. It's really quite an interesting effort. It's a voluntary effort, so let me tell you a little bit about that. The motivation for this is indicated here on this vision slide. Cyber-physical systems is a term we use for hybrid engineered and IT systems. So an autonomous vehicle could be a cyber-physical system, or a smart grid and a network system, and so on, all count as examples of cyber-physical systems. But today, one of the challenges is that these smart systems are often implemented one by one. And so a city might implement a water management system and simultaneously a smart grid or an energy management system, but those two systems typically don't talk to one another and don't interact. And so although water systems are a major consumer of energy, those two systems wouldn't interact. And so what we wanted to do is demonstrate the value of being able to connect cyber-physical systems of different types in order to create new capabilities. So that was the motivation. The challenge that we issued was not just to demonstrate technologies for the sake of technologies, but rather to demonstrate that this implementation of interoperable systems makes a real difference, that it can drive job creation, economic growth, new businesses, and it can improve the quality of life and even save lives. So those were the criteria for success that we asked the teams to step up to. And I'll show you a few examples, but they were remarkably capable in doing that, with one of the teams, for example, creating a whole new manufacturing business here in the United States with a large number of new employees, new jobs, and interesting growth. So that was the challenge that we issued. Yeah, in the end, we had more than 100 organizations that organized themselves into 24 teams to participate in the challenge. We launched this in the last December, and we just a week ago had an expo to highlight the outcomes. And participants came from industry. You can see a large number of companies that participated in this challenge. I'll show you some examples in a moment. A number of universities and research institutions from across the country were participating as well. And we had good participation from a variety of agencies at different levels. So the U.S. Department of Transportation, the Department of Defense, Department of Homeland Security, Health and Human Services, and we even had a county government, Montgomery County in Maryland, in the state of Maryland, was also a remarkably capable participant in a public safety challenge. And we're an interesting part of this process. So we had these 24 teams. Here's some examples of the areas in which they were participating. And this ranged from healthcare and energy through autonomous vehicles and smart rooftop installations. And so I think the point that this makes is that smart cities arise from a wide variety of different types of applications and infrastructures. And so creating a truly smart city is about creating a wide variety of systems that enable city operations and improve the quality of life. And it's not limited to any one specific area. And so I think a big advantage in this challenge was opening it up to all possibilities, and we really got a really interesting range of responses. So here are some of the examples. This was an effort put together by AT&T and IBM centered on an energy application for transactive energy. And transactive energy is an emerging approach that uses market forces to match supply and demand for more agile and responsive electric grids. So this provides greater options for consumers, and it enables more efficient management for suppliers. So IBM and AT&T are developing a transactive energy management platform that can manage diverse devices, systems, and control signals along the supply chain and create a market-driven grid system. So IBM in this case provides the computational platform, and AT&T provides the machine-to-machine services, smart grid device connection points, and a data platform. And so the overall goal here is to use market-driven mechanisms to save energy, increase reliability, reduce outages, and give customers options for controlling their own energy and energy resources. In another example, this was a large number of organizations that came together to create systems for disaster response or emergency response. So this program, SERS, or Smart Energy Response System, integrates a range of cyber-physical systems from autonomous aircraft to agile robots, censored search dogs, disaster area ad hoc networks, and rescue animals and first responder teams. And the idea is to provide quick response capabilities, comprehensive awareness, and effective resource applications to save lives and speed recovery for the full spectrum of disaster scenarios. A large number of teams, participants were from the University of Washington, from Blue Haptics, this is a telerobotics company, National Instruments for robot systems and software, MathWorks for dispatch system, Boeing provided drones, aerial drones, MIT Media Lab and the University of North Texas provided communications network systems, and the University of North Carolina had instrumented search and rescue dogs, with Worcester Polytechnic providing humanoid robots. So this was a really broad effort creating capable disaster response systems. Here's another example that was a joint effort of Honda and Qualcomm. In the U.S., we have the positive development that the number of traffic fatalities is going down over time, but unfortunately the number of incidents involving pedestrians is going up. And so in the area of intelligent vehicles, this is an effort to address that problem. And so here the vehicle is aware of its environment and can detect pedestrians in the environment and alert the driver. But not only can it alert the driver, it can alert the pedestrian through their cell phone to a safety-critical situation. And so this expands the typical vehicle-to-vehicle or vehicle-to-grid kinds of concepts to a vehicle-to-people or pedestrian kinds of concepts. A really interesting extension of that notion. This example was on smart water assets, and it was Qualcomm and CH2M Hill. And this team is using advanced communication and IT to help utilities save water, reduce wastewater overflows, improve public safety, and enhance customer service, including the ability to detect leaks, and not just the fact that there's a leak, but some information about the location of that leak, to manage water quality, effective distribution, and coupled to energy services as well. And it was Jason Ellis of Qualcomm who was the leader of this team. So an interesting water management example. Another project involving Qualcomm and a variety of participants, including Audi focuses on smart roads and smart transportation. The Smart Roads effort uses advanced sensors and control systems to manage traffic flows as an effort to reduce congestion and travel time, increase safety, improve fuel efficiency, and reduce transportation costs. The team is, in this case, demonstrating a secure, reliable, and effective smart road implementation that is actually in place on the Interstate 15 highway corridor in San Diego, California. So they have an actual implementation strategy. A related team was using advanced smart vehicles to communicate not only for comfort and convenience, but for safety, crash avoidance, emergencies, and other critical functions. This was led by the U.S. Department of Transportation and was run in the Southeast Michigan region. They teamed up with Next Energy to create an electric vehicle application that's based on an open, resilient vehicle communication platform that the Department of Transportation here has developed. And their long-term goal is to use this platform for applications that provide for traffic rerouting, smart parking, and a variety of other applications like smart traffic lights that recognize when there's a vehicle waiting in one direction, no vehicles coming in the other, and can respond to that situation to create more efficient traffic flows, reducing time for travel and fuel consumption at the same time. This is an example for in the healthcare arena. This is a team that has grown remarkably over time. And the goal of this team is to transform a medical system focused on medical providers and medical systems to one that's focused more on individuals and patients and their care. It integrates home, primary care, hospital, assisted living, and pharmacy capabilities into a seamless personal care system for an improved quality of life. Projects led by Julian Goldman at Massachusetts General Hospital and by Mark Skubik of the University of Missouri. Other participants are the University of Pennsylvania, Vanderbilt, Worcester Polytechnic, Underwriters Laboratory, DocBox, the U.S. Department of Defense, Intel, Z-Wave Alliance, RTI International, PrismTech, Nanotech, Talend, Queralt, and Proactive Sense. So this is a very large, very interactive team creating highly integrated healthcare infrastructures focused on the patient. So you can see from this set of examples, this is only a few of the 24 that emerge, this challenge for voluntary participation to demonstrate the impact of integrated infrastructures on quality of life, on safety, and on efficiency turned up a remarkable number of examples and a lot of very strong technology innovation. So having these demonstrations, we want to move on to the next step, and we're calling the next step in this process the Global Cities Challenge. We want to launch this in September of 2014, so we're putting in place the infrastructure and getting ready for that launch. And the primary goal here is to move from the demonstration projects that were at the heart of the Smart America Challenge to deployment at scale. And another important feature is to move from what is a national effort to what we hope will be an international effort. And I'll talk about that more in a minute. But a central concept of this challenge is to create what I'll call action clusters. And these are teams of cities who are working, each working on a similar technology challenge. They might be working on smart building management, or they might be working on water management systems. But the cluster is a set of teams who are working on a common technology challenge. And the goal is to, by working together in clusters, to reduce the time and costs for smart cities deployment. So let me say a little bit about how this might work. So on the one hand, we have a wide variety of smart city projects going on around the world. In the U.S., participating in the Smart America Challenge were the cities of San Jose, Detroit, Austin, a number of others that are not listed here, like San Diego, California. Also, Washington, D.C., Montgomery County, and a variety of others. So we have a number of smart city projects going on in the U.S. You'll hear in a moment more from Gilly about some of the European efforts, wide variety of really interesting and aggressive smart city projects for cities across Europe. Other cities in Asia, in Singapore, in Japan, South Korea, and others involved in smart city projects, and the list goes on with Australia, Africa, South America, and more. And so we have around the world a large number of cities who are in the planning and project phases for important smart city projects. On the other hand, as we were able to show in the Smart America Challenge, there are a large number of innovative technology folks out there today who are working on novel sensor systems, important strategies for cybersecurity, communications and networks, infrastructure projects, cloud services, utilities, robotics, and we'll hear more about building controls from Stephen here in a bit. So we have these two sets of efforts, and the idea is to bring these two kinds of organizations together in action clusters. And a cluster might be organized around, for example, coordinating energy management with air quality and traffic management. One of the Smart America projects is organized around that kind of activity. On the other hand, we might have cities who are focused on sustainable implementations and green technologies. Others with interest in emergency response and disaster resilience. Yet others on building design or energy systems, and the list goes on. All of you can think of more examples of this. And so around each of these technologies, we might bring together teams of cities from the U.S., Europe, Asia, South America, and elsewhere, who are all focusing on a set of common technologies, and connect those cities and their efforts to technology innovators who have innovative technologies that can facilitate those efforts and help to meet the city goals. So that's what we'd like to do in global cities. So what's the motivation? Why should cities and innovators and governments participate in this effort? And here's some of I think, the benefits that can emerge from an effort like this. So for the communities, the cities, the regions, the nations, you can reduce the time and cost of smart deployments by connecting to innovators with efficient, low-cost technologies, and you can leverage your investments by working together with other cities who are investing in the same kinds of technologies. If you're an innovator, you can advance your technology effort and connect to customers by demonstrating that your solution works not in just one city or one application, but actually works across a range of different city implementations. Also gives you a chance to test your technologies at scale, and that's hard to do in a real implementation environment, but by working with cities, one could do scaled pilot deployments to demonstrate effectiveness and function. For governments, whether these are local, state, national, or regional governments, this is a way to promote smart city economic and social benefits. And a key issue here is, rather than deploying solutions city by city, where two adjacent cities might implement a water management system that's different in each case. And so for when you walk up the chain from a city to a region or a state, cities across the state might not be interoperable. Yet in the global cities strategy, that interoperability, for example, for transportation management, would extend from a city to a county, to a region, to a state, to a nation, for broad management capabilities. The part of the challenge also is to try to reduce deployment costs and to speed adoption of smart cities efforts. So in summary, this is an effort we'd like to launch on top of the earlier effort where we were able to identify innovators. We want to launch in September of 2014. This slide shows some contact information for the folks who are involved in launching that. And stay tuned. We'll be sharing information with the CIB task group about that launch process. And we hope that many of you will be able to join us. So with that, let me turn the desktop back over to Tom.